Are you one of the students who are afraid of energy profile diagram? By the end of this video, that phobia will disappear because I'm going to take this question step by step. Now follow me. In an equilibrium reaction between gases Q2 and R2 to form QR, the energy content of the reactants is 100 kilojoules and that of the product is 54 kilojoules. The energy content of the activated complex is 210 kilojoules. 1. Draw an energy profile diagram for the reaction. 2. Determine the activation energy EA and the enthalpy change delta H. Now, energy profile diagram is a graph that shows the energy transformation from the reactant to the activated complex and to the product. And from the graph, you are able to get the activated complex, its energy, which is activation energy, and the enthalpy change. The vertical axis of this graph is the energy axis in kilojoule, and the horizontal axis of the graph shows the reaction pathway. Because the highest number here is 210, we have to divide this vertical axis so that it will accommodate 210. We can do 50, 100, 150, 200, 250. You can see 210 is accommodated. Now, the energy of the reactants is 100. So you start from 100. The graph goes like this, constant, no increase in energy, no decrease. So you represent the reactants as Q2 plus R2. Now, when they begin to absorb energy to react, the graph will start sloping up. And before they form product, they will form what is called activated complex, whose energy is 210. So, as if you pass 200 a bit, 210, then you come back to the product, whose energy is 54. So, you are going to come down to almost 50. Yeah, 54. Here is the activated complex, and here is the product QR. QR, the energy is 54. You trace it. Then the reactants, the energy of the reactants is 100. You trace it too. Now this is the activated complex, activation energy, EA. Here is the delta H, enthalpy change. And this is the energy profile diagram. The reactants have the energy 100, and when they start to react, the energy increases up to 210 kilojoules. An activated complex is formed, and then this activated complex loses energy to 54 kilojoules where the product exists. This is the energy of the activation or activation energy, and this is the enthalpy change delta H. And this diagram just answers question I determine the activation energy EA. This EA, there is a number for it. It is from here, from 100 to 210. So you say activation energy equals energy of the activated complex 210 minus energy of the reactant, which is 100, and you are going to get 110 kilojoules. And then the enthalpy change. Enthalpy change is gotten by subtracting the energy of the reactant from the energy of the product. So enthalpy change is energy or enthalpy of the product minus enthalpy of the reactant. Enthalpy of the product is 54. That of the reactant is 100. 54 minus 100 will give you minus 46 kilojoules. And you see this negative sign? It tells you that the reaction is exothermic. I hope you got value. If you did, click on like, comment, share the video, tag your friends, follow and subscribe to my YouTube channel.